November 2017, paper 4, variant 2. Question 1 بيقول dust particles in the air move around in a random way. What term describes the random movement of dust particles? Of course, it is the Brownian motion. It's not diffusion. Diffusion is the movement from high concentration to low concentration. Identify the particles in the air which cause the random movement of the dust particles. You either say nitrogen or oxygen molecules. Air particles is not an accurate answer because there's nothing called air particles. Air is a mixture from nitrogen, oxygen, carbon dioxide, and noble gases. If I choose one of the components of air, the best choice, of course, is nitrogen because it's 78%. Explain why the dust particles move in this way: because the nitrogen or oxygen molecules collide randomly with dust. 1 mark for collide, 1 mark for randomly. Also, this motion is called the motion that's caused by the collision is called the jerky motion or the zigzag motion. B, when chlorine is put into a gas jar, it spreads out to fill the gas jar, and bromine also spreads out, but bromine takes a longer time than chlorine. Of course, this is diffusion because it's the movement from high concentration to low concentration. So this is the type of the movement. Then he says use the data from the periodic table to explain why bromine takes longer. When he says use data, you should state numbers. So bromine molecule weighs 160 while chlorine molecule 71, or at least say that the bromine atom weighs 80 and a chlorine atom 35.5, and therefore bromine diffuses slower than chlorine. 1 mark for comparing the numbers and 1 mark for stating that bromine will diffuse slower. Okay. Explain why increasing the temperature increases the rate at which particles spread out, because particles have more energy and therefore they move faster. They have more energy or move faster was also accepted as an alternative answer. Okay, completing the table, silicon has 14 electrons, so it's 284. Calcium has 20 electrons, but it's a positive 2 ion, so it lost 2 electrons, so it's 288 only. Nitride ion, nitrogen has 7 electrons, so it was a 2 and a 5, and then it gained 3 electrons, so it became 2 and 8. The formula of the compound formed between calcium and nitride is Ca3N2. You just switch the valencies. This is the dot and cross diagram for lithium chloride. It's important to make 1 electron in a different shape than the other electrons of chlorine, and there is also 1 mark for the charges. Sulfur dichloride is the drawing of the dot and diagram to draw the bonding pairs and the lone pairs of sulfur. The bonding pairs are for 1 mark, the lone pairs of sulfur are for 1 mark, and the lone pairs of chlorine are for 1 mark. Okay, all elements should have 8 electrons in the outer shell. E, in terms of attractive forces, explain why lithium chloride has a higher melting point than sulfur dichloride, because lithium chloride is ionic, so it has strong electrostatic forces or strong anionic bonds which need high energy to break, while sulfur dichloride has weak forces of attraction between molecules, okay, between molecules, or at least say weak intermolecular forces of attraction which need low energy to break. You have at least to state 1 time that these bonds need high energy, or at least say that these bonds need low energy to break for taking the 3rd mark. So 1 mark here, 1 mark here, and 1 mark either here or here. Suggest the identity of a covalent compound with higher melting point than lithium chloride. The only acceptable answer is silicon dioxide, because the diamond and graphite are not compounds. A compound is made of different elements, not of only 1 element like diamond and graphite. Question 3 is about energy level diagrams. Of course, this is the combustion of ethanol. So he wants an energy level diagram. You will complete it like this. 1 mark that the products are below the reactants. 1 mark that you wrote the products exactly as they are in the equation. You just copy them down there. And the 3rd mark is for drawing the arrow of the delta H, only 1-sided arrow pointing downwards. What does X represent? Of course, this is the activation energy, which is always, by the way, in a positive sign. This is the calculation of delta H, okay? So you take care that this is the combustion of 2 moles of methanol. You need to get all the bonds that you broke. So you broke 6 CH bonds, you multiply by 2, and 2 CO bonds, and 2 OH bonds, and 3 O double bond O bonds. Okay, by substituting the values, the answer will be 5,600, which is the energy needed to break the bonds. Then you will analyze what are the bonds you formed. So you formed 2 C double bond O bonds times 2, so there are 4 C double bond O, and 2 OH bonds times 4, so they are 8 OH bonds. Okay, so this is 6,900 kilojoules. The delta H is energy in minus energy out, so it's negative 1,300, but take care, he wants it for 1 mole of methanol, and this delta H is for burning 2 moles of methanol. So you need to divide by 2, and the final answer is negative 650. If you didn't get the divided by 2 part, you only lose 1 mark. Question D, name the process occurring in stage 1. In stage 1, he broke an alkane containing 12 carbon atoms, and he made it into 3 molecules of ethene and a molecule of another hydrocarbon. Of course, this is cracking, breaking long hydrocarbons into shorter ones. Write the chemical equation. So C12H26, which he already gave you the formula of by stating that this is dodecane with 12 carbon atoms. An alkane, if it contains 12 carbon atoms, it must contain 26 hydrogen atoms. Use the general formula of alkanes to know that. And then you crack this alkane and produce 3 molecules of ethene. Okay, so don't forget this 3. Then you will, the only remaining elements will be 6 carbon atoms and 14 hydrogen atoms. So this is the equation. The conditions needed for stage 2. Stage 2, he turned ethene to ethanol. This is the hydration of ethene. You state 2 of these 3 conditions, either 300 degrees Celsius, 60 atmospheric, and phosphoric acid as a catalyst. Then he wants the type of reaction. Of course, the best answer is hydration, but addition was also accepted. Suggest how we can test the purity of ethanol by measuring the boiling point. It should be sharp. You also can say it should be 78 degrees. Okay, ethanol can be made also by fermentation of glucose. He wants 2 conditions for the fermentation of glucose, 37 degrees Celsius, yeast, anaerobic conditions, any 2. Then completing the reaction, okay, ethanol after, glucose after fermentation produces ethanol and carbon dioxide gas. The balancing is 2 and 2 because we have 6 carbons here, so we need to have here 4 and here 2 for the carbon atoms to be balanced, and also the rest will be balanced automatically. Suggest why the concentration, the triple I, suggest why the concentration of ethanol produced by fermentation does not exceed 15%, because as we said before, at 15%, this concentration of ethanol is toxic for the yeast and the yeast is killed by ethanol. One other disadvantage of manufacturing ethanol by fermentation is that it has a very slow rate because the temperature must be set at 37, and increasing the temperature above that will denature the enzymes in the yeast. Another advantage, question V, another advantage for making ethanol by fermentation is using renewable feedstock or renewable resources because we use glucose, which could be obtained from sugarcane. VI suggests the name of a process to obtain ethanol from a mixture of ethanol and water. Of course, this is a liquid-liquid mixture. They are miscible liquids separated by fractional distillation. Okay, question F. Ethane 1,2-diol has the following structure. Write the empirical formula. To get the empirical formula, you first get the molecular formula by counting the number of carbons, the number of oxygen, and the number of hydrogen present. And then you try to simplify. Okay, you will divide this by 2 and this by 2 and this by 2. You will get the empirical formula CH3O. Okay, double I, he is asking why ethane 1,2-diol cannot undergo addition polymerization. This word means automatically that there is a double bond between 2 carbon atoms. This structure doesn't contain the double bond, so the answer is simply that there is no carbon-carbon double bond. Ethane 1,2-diol undergoes polymerization with molecule Y, and he gave you the monomers, and he wants you to draw 1 repeat unit. You don't even need to draw the bracket ends, since he said that he wants only 1 repeat unit. Okay, this will be the final answer. Take care from the continuation bonds, and take care from the ester linkage, and take care to order the boxes to make one shaded and one unshaded. Okay, a mark for the continuation, a mark for the ester linkage, and a mark for writing the boxes in the correct form. Okay, you'll just remove water, OH from the acid, H from the alcohol. Here you remove an H from the alcohol, and here you remove the OH of the acid. Name the type of condensation polymer formed. This is, of course, it's a polyester, and it's easily noticed from its ester linkage. A student sets up the following electrolysis experiment. Define the term electrolysis. It's breaking down molten or aqueous ionic compounds by electricity. 1 mark for the first sentence and 1 mark for stating that it's done by electricity. Name the gas produced at the anode. Of course, dilute sodium chloride has 4 ions, NaCl, NH, and OH. At the anode, OH will be discharged because the solution is dilute. And when hydroxide go to the anode, it changes to oxygen. So this is the gas. Describe a test, glowing splintry lights. This test for oxygen. Half ionic equation for the reaction at the cathode. Of course, the less reactive element is discharged at the cathode. Hydrogen is diatomic, so they move in pairs. 2 hydrogen ions will gain 2 electrons to form a hydrogen molecule. Okay, C, what is the type of particles responsible for the transfer of charge in the wires? In the wires, electrons move, and in the solution, ions move. This, by the way, is called the external circuit, and this is called the internal circuit. Okay, so electrons move in the wires, ions move in the electrolyte. D, the student replaces dilute sodium chloride with concentrated sodium chloride. What are the 2 differences he will observe? Of course, in case of concentrated sodium chloride, the main difference will be that chloride ions will be discharged as chlorine instead of OH. So green bubbles will be produced at the anode. And since the solution became more concentrated, the rate of bubble production will increase and the bulb will be brighter because concentrated solution provides more free ions, okay? So the green bubbles at the anode and the bulb will be brighter, or the rate of bubble production will increase, okay? Then he's talking about refining copper, and he's asking to label the apparatus. The labels, of course, will be impure copper as the anode, pure copper as the cathode, and aqueous copper sulfate as the electrolyte. It's very important to take care that the impure copper is the anode and the pure copper is the cathode. Don't switch them. Okay. Then he's asking what may happen to the silver impurities and the zinc impurities. This is a very important and hard question. The electrode of impure copper is, of course, made of copper and of other impurities like silver and zinc. And we have an electrolyte of copper sulfate. Okay, after the electrolysis takes place and copper atoms fall into solution as ions, okay, silver and zinc, or whatever the impurities are, fall at the bottom and form something called the anode sludge. Silver is less reactive than copper, so it won't react. So silver just falls at the bottom. But zinc is more reactive than copper, so it will displace it and form soluble zinc sulfate. So the zinc will dissolve as it displaces copper in the solution. So silver impurities just fall out at the bottom because they are unreactive. It won't react with copper. But zinc impurity, zinc is more reactive than copper, so it dissolves or reacts with copper sulfate. Okay, silver doesn't react, zinc reacts. Okay, then he gave an equilibrium question, question 5. He gave you the equation and the colors of whatever you will need, okay? And then he's asking, in terms of Y, of position of equilibrium, what would you see if sulfuric acid was added to Y, solution Y? Okay, to think about equilibrium questions, you need to understand exactly what's happening. Equilibrium is keeping the rate of the forward and backward reactions equal. So when you add sulfuric acid, you increase the left side, so equilibrium would start shifting to the right and moving, favoring the forward reaction to increase the right side. So you will see more orange color. Equilibrium will shift to the right, takes 1 mark, and orange color in the solution increases, takes the second. Explain in terms of position of equilibrium, what would you see if sodium hydroxide was added? This is a very tricky idea that he gets regularly in equilibrium questions. The problem is that sodium hydroxide is not available in the equation. It's not part of the equation. But take care, sodium hydroxide is an alkali, so it will neutralize the acid, decreasing its concentration. So equilibrium will shift backward and increase the concentration of the reactants, and thus the yellow color will increase. So sodium hydroxide neutralizes sulfuric acid or reacts with it, takes a mark. Equilibrium moves to the left, takes a mark, and the yellow color increases, takes the third mark. Question B, Mole's question, a very simple one. He says that hydrogen could be manufactured using this reaction, and he says that the yield of hydrogen at 900 degrees is only 70%. 70% of the total amount is only produced. And then he asks what volume of hydrogen is produced from 100 centimeter cube of methane under these conditions. Since this equation is all gases, we can use the volume ratio directly. So 100 centimeter cubed of methane will produce 300 centimeter cube of hydrogen, since the volume ratio is 1 to 3. But only 70% of this is produced based on what he said in the question. So 70% of 300 is 210 centimeter cubed. No need, of course, to turn this value into decimeter cube because he wants the answer in centimeters cubed. And then he says, under different conditions, different yields of hydrogen are obtained. If the pressure is increased, the yield of hydrogen becomes less than 70. Explain why. Why does the yield of hydrogen decrease when we increase the pressure? Increasing the pressure shifts equilibrium to the side with lower moles. This is the rule of Le Chatelet. Okay, so when we increase the pressure here, the left side has 2 moles, one steam and 1 methane. The right side has 4 moles, 1 carbon monoxide and 3 hydrogen. So equilibrium will shift to the left, to the side of lower moles and lower yield of hydrogen. Equilibrium shifts to the left, takes mark, because it has lower moles, takes the other. If the temperature is decreased, the yield of hydrogen decreases. What does this tell you about the reaction between methane and steam? Okay, when he says the reaction, he means the forward. When he doesn't state which one he's talking about, we assume it's the forward reaction. If he decreases the temperature, okay, if he decreases the temperature, the yield of hydrogen decreases. Let's think about it. When he decreases the temperature, equilibrium favors the exothermic reaction in order to attempt to increase the temperature again. Okay, equilibrium increases the temperature because you lowered it. Type, what if he says that when he lowered the temperature, hydrogen decreased? This means that the backward reaction was favored. This means that the backward reaction was exothermic, since you are lowering the temperature, so equilibrium is trying to resist you. So this means that the forward reaction is endothermic. Okay, it's endothermic. Why is a catalyst used in this reaction? Catalysts are always used to increase the rate of the reaction. This was November 2017, paper 4, variant 2 by Mr. Marco Medhat.